This quick little video I made to show you the similarities and the differences between empirical and molecular formulas. So empirical formulas are chemical formulas that give the simplest whole number ratio of the atoms in the element. So for example, if we had an empirical formula of C4H10, we know that the common denominator between 4 and 10 is 2, so we divide by 2 to get C2H5, and that would be our empirical formula. Okay, so empirical is the quickest, easiest version. Okay? Next is the molecular formula. And the molecular formula is something that you've always seen. So every formula that you've seen until now is a molecular formula, meaning that is the actual number, or the exact number of things. So the actual number of atoms in each element. So for example, if we want to look at butane again, which is in your lighters, the actual chemical formula is C4H10. So if we wanted to go to empirical, like on the last slide, we divide everything by 2, but the molecular formula is actually the true formula. But sometimes they can be the same. So, for example, carbon dioxide, which is CO2, the empirical and the molecular formula are the same. So you're never quite sure. So the question kind of has to tell you or guide you in some direction when we're looking at the math of this. So our first example looks at what is the empirical formula for a compound that contains 27.3% carbon and 72.07% oxygen. So we know that it's it's asking what is the empirical formula. So we know we're going to have to solve, and we're going to have some formula that has a C in front and an O in front, but we're not 100% sure what the subscripts are yet. Okay, so there's quite a few steps involved with this, so if you write down the steps, follow them every time, you'll be 100% successful, hopefully. Step 1, assume you have 100 grams of the compound and change the percentage sign to grams, so just as it's stated. So the 27.3% and the 72.7%, you're just going to change it. So it looks like 27.3 grams and 72.7 grams. There's zero math here. All you're doing is just changing the percent sign to the grams. Okay? So the next step is to actually calculate how many moles you have of each element. So you're going to set up your conversion factor. So for carbon, okay, I know I started with 27.3 grams. Okay, I'm going to draw my bracket, draw my line, and I know that 1 mole of carbon is equivalent to 12 grams. If I look it up on the periodic table, I'll do the math. So I'll take the 27.3 and I'll divide it by 12, and I'll get the answer of 2.27 moles. Okay, because the grams and the grams cancel out. I do the same thing with the O. I have 72.7 grams. Do my conversion bracket. 1 mole of oxygen is equivalent to 16 grams. And then I make it equal. I do the math, so 72.7 divided by 16 is 4.54 moles. Okay, so I have 2.27 moles of carbon and 4.54 moles of oxygen. Okay, so the next step is kind of wordy and complicated, but the understanding is that you're going to take the smallest mole number or whole number ratio of these mole amounts by dividing the amount of moles by the smallest number of moles. Pretty wordy, right? Go back to the last step and look. So I had carbon. I wish there was an easier way to change the color on this thing. Okay, so carbon had 2.27 moles and oxygen had 4.54 moles, right? Okay, who's smaller? Obviously, the carbon is smaller. So I'm going to divide each moles by the smallest moles. So 2.27 divided by 2.27 is equal to 1. And 4.54 divided by 2.27, it's got to be roughly 2, right, is 2. Okay? So I have numbers. I have a 1 and a 2 now. So the last is just to write it out using those numbers. So the C and the O, okay, the C was a 1 and the O was a 2. I'll clean that up a bit and I'll put CO2. Okay? So the percent composition of carbon dioxide is 27% carbon roughly and 72% oxygen. So that's how you find an empirical formula. I'm going to do another short little video to show how you convert an empirical formula into a molecular formula.